Hello everyone, and welcome to Application Development with ASP.NET with your host, Mr. Nelson Locator. Nelson.
Hey.
Hey. Also joining us tonight, Mr. Zach Parrish.
Good evening.
And myself, Jason Busby. Now, over the last couple of episodes, if you guys recall, we took a look at, a closer look at Autofac, and then we moved into a look at Fluent and Hibernate so that we could move away from our XML mappings. Now in this video we're going to begin coding the project again, but making use of the things that we've looked at and a better structure for this application. So with that, let me go ahead and hand it over to Nelson so that he can talk a little bit about what we're going to be doing.
Yep, so we're going to be, creating kind of the different projects that we're going to have. We're going to be defining what those projects are there for. Getting Autofac set up properly, getting in Hibernate, mapping our stuff, creating a basic web application thing with a few controllers in it, or probably one controller by the end of this video, and then so then we'll have something that we can start actually coding on, which would be great.
Awesome. Okay.
So I'm going to start with a new project, and it's going to be a solution.
And
I'm gonna have problems with these spellings.
And we can go ahead and point out that
Honey
it was Honey Bomb. That's awesome. We will point out that it was Gavin, Fat Gav over on 3D Buzz, that had the suggestion for using the name Honeycomb. So we will use that name as
just a code name.
Just the working title for this project, because it was very cool and it does go along nicely with 3D Buzz.
All right, I'm gonna go ahead and close the solution I just created. And then I'm going to create our source and lib folders. I'm going to drag the solution into the source folder. And then I'm going to yank these out of the Honeycomb folder. And then I'm going to launch the solution again.
Okay.
And close this instance of Visual Studio. And wait.
And wait.
You think an empty solution wouldn't take this long to load?
Fool. And wait some more.
But we get the cool pinwheel.
Actually it doesn't translate over TeamViewer.
Well, we had it for a minute anyway.
Okay, so the first project that I'm going to create is going to be the web app, which is going to be an ASP.NET MVC3 web application. And it's going to be empty, and we're going to select Razor, even though we're not going to be using Razor. Then I'm going to do some things. I'm going to delete the content folder, the models folder, and the scripts folder. Then I'm going to... that's good. So then we need to start creating our project. So I'm going to go ahead and just create all these projects. They're all going to be class libraries, except for one. And I'll talk about what they do once they get all created. This is the really fun part.
Well, so far I think we're jamming along nicely, and everybody should be able to follow. You think you could follow so far, Zoe?
I think so.
Awesome.
I do feel like I should be putting in some sort of filler dialogue, though.
Oh, should you?
Yeah.
Isn't that what you're doing now?
No, not yet.
Well,
I mean, not officially. I was just talking about the idea of putting in filler dialogue. This, of course, doesn't count.
Services.
Yeah, it's TeamViewer.
It's the lag.
It's always the lag.
It's always the lag with you. Oh, Honey Bomb again. Awesome.
I know, we should really reconsider our naming.
Yeah, I have a problem with typing out Honeycomb. I don't know why.
You want to type Honey Bomb. That's clear. That's what I'm seeing, anyway.
I don't see a problem with that.
No.
All right, let's see if I can do this right this time. There we go.
Right.
necessary. Whoa. That just came out of nowhere.
That was a lag.
It must have been.
Totally.
It's a hotkey combination you hit last week. It's just now getting here.
Visual Studio, that's not surprising. Alrighty, so here are our projects, and we're going to set this guy as our startup. Yeah, so our base project is going to contain the interfaces for the infrastructure that we're going to be consuming in the rest of our project. So it's going to contain things like, iSession service, iConfig providers, stuff that, no implementation details, but stuff that the entirety of the solution is going to have to depend on.
Okay.
Honeycomb.domain is going to contain the aggregates and the services and the repositories for all of our domain objects. And once we start actually filling this project out with stuff, we'll talk about that terminology and how to put it together properly. The query model is kind of interesting. So basically, in this particular architecture, we're going with a kind of pseudo CQRS or pseudo command query responsibility segregation. Yeah, kind of architecture where we have basically two models that we interact with, one being the domain, which performs operations, and one being the query model, which gives us back data. And the domain model, the domain model contains all of the logic, the business rules, and everything. The query model just exists for us to be able to pull data back, but more importantly, to be able to pull data back without the data that we're pulling back having any attachment to business logic. Mm-hmm. So what we're going to be doing is in our domain, we'll have like a thing like a user or a task or an issue or project or whatever, and then we'll have those same objects in the query model. The difference being is that the ones in the query model will have no behavior attached to them. They'll be really plain entities with public getters on all their properties and private setters on all their properties, and they won't have any methods. And what we're going to do is we're going to map the corresponding entities from our query model into the entities of our domain model. So the two entities, there'll be a one-to-one, or most of the time there'll be a one-to-one relationship between the entities here, and they'll both be mapped by Hibernate to the same table, so they'll pull out the same data. But we're doing it in a way that doesn't, it's just better. It sort of allows us to, traditionally what we would do is instead of having a query model, is we would have a domain, and we have a bunch of DTOs, and those DTOs would be auto-mapped or something mapped, or those domain objects would be auto-mapped or something mapped to DTOs, and then they would be sent back up to the chain. I prefer the segregation between these two concepts because at this point, when you're talking to the query model, you're just talking to repositories. When you're talking to the domain model, you're just talking to things like services or command invokers or something like that. So when you want to get something done, you talk to the domain. When you want to read something back, you talk to the query model. And that separation allows you to do a lot of cool things, especially with how you store the data. And in this, at least in the beginning, like I said, there will be a one-to-one mapping between the entities in both these models, and they'll both be mapped to the same table. But eventually, because we have the separation, we can persist our domain objects however we want, and we could do things that would be very beneficial for a project that has things like tracking changes. Like certain entities, we might want to choose to event source them or do something else more complicated, but we don't want that to affect the read model or the query model, and we especially don't want to affect how that is read in from our web app. So creating the separation early on gives us the flexibility to do whatever we want to do in the future with the domain.
Okay.
So now we have our services. Our services are going to be more or less non-ASP.NET specific implementations of the things defined in our base. So remember, the base is going to contain interfaces that these layers, every layer other than the services folder or the services project, are going to depend on. They're all going to depend on the interface as a base, but the services folder is actually going to contain most of the implementation details for that. Then we have the web. The web is going to essentially be kind of like the services project, but it's going to be implementation of services that are specific to ASP.NET MVC. And the reason that I decided to break these two things apart, to separate between things that are dependent on ASP.NET MVC and things that aren't, is because of these two guys, the web app and the console. The web app and the console are basically the front ends to this application. And the web app will reference all of these projects up here. The console will reference every single project except for the .web, and that's why that separation exists, so that inside the console we can provide our own implementations of the base services without being in any way tied to ASP.NET MVC. And of course, because we'll be using Autofac and IOC, we could create a third, maybe like a WinForms app or whatever, and provide completely different implementations for everything in base. But I just decided that the separation between these two projects makes things a lot more clear.
So for those that are following along that may be a little confused at the moment, obviously the web app, as you said, the front end is going to be the web application that people will be using to interface and work with projects. Do you want to take just a second and explain what your thoughts are behind the console project?
Well, the console project is going to, conceptually it's going to have access to the entire domain model and the entire query model, which means we'll be able to do virtually anything to our application using the console app. So the idea is to provide sort of an administrative area for the console. We could also do things like automation of tasks for build processing and or building, and we could automate the creation of additional users and tenants and all that cool stuff, and we can do that all through the console without having to spool up a web app.
Right.
And of course, having this separation early on will force us to code in a way that everything up to here, so base, domain, query model, and services, has zero dependencies on system.web, meaning we could conceivably create a Honeycomb.wpf application, or whatever we need to do.
Awesome.
So yeah, and you'll also notice that they're sorted properly, and it actually, Jason and I spent some time coming up with the names to get them to do that, and I always try to make sure that they sort logically, so it's not an accident that every subsequent project depends on the ones above it, with the exception of tools, because I couldn't figure out how to get console to sort before everything else. But whatever, that's fine. Yeah, so I guess we can now kind of get started coding. I guess the main kind of entry point into Honeycomb is going to be the Honeycomb host. And we're going to put that in the services abstract namespace. And I could do this. I could do services, and I could do abstract. But like I said before, we're not going to be... This is generally... I never really called this out, but people have probably noticed that I do this, where when I have a namespace and I have a bunch of abstract classes or interfaces in that namespace, I always bring them up to an abstract folder, just because I find that the interfaces sorting sandwiched in between the concrete implementation, starting with the letters before and after, it irritates me. So putting in the abstract gives us a nice little area to put our abstract stuff. But because this project is not going to contain any concrete implementation, I'm not going to do this. I'm going to actually do services.abstract. And this will be under the services.abstract namespace properly.
Okay.
So the most important interface, like I said, is going to be the iHoneycomb base or host. And all he's going to do is he's going to have a begin request and an end request. So this interface doesn't really do much, but it's going to be a very important thing once we start talking about multi-tenancy, and we're going to be expanding it more in the future. But the concept of a request is going to be pretty important in the context of our application, so we're just going to go ahead and put that there. So I guess now the next thing to do is to set up I guess we could do the web app first.
Okay.
Because we kind of have already been talking about ASP.NET MVC and all that stuff.
Mm-hmm.
So what I'm going to do with the web app, I'm going to go with global ASICs. I'm going to nuke all this stuff. because we're actually going to define all this functionality inside of our .web folder. And he's not going to inherit anything because we have to create some sort of application class that is going to sit between. It's basically going to encompass everything that this global ASICs would do. And he's going to inherit from HTTP application. Yes, we're going to reference system.web. Unfortunately, there we go. I don't know why ReSharper does that sometimes. It says, do you want to import this DLL? And then you tell it to, then it says it failed, but it really did import the DLL. It just didn't have the using statement.
Right.
I don't know. That's kind of weird.
Yeah.
And our application is going to implement Honeycomb host, which will bring in our honeycomb.base. And that time it decided to work. And so now we're going to go ahead and implement all of our members, our begin request and our end request. There's actually an interesting note. Right here, you'll see that the keyword new is required in begin request because it hides event handler system web at HTTP application begin request, which is an unfortunate thing because this is HTTP application actually defines a begin request and an end request, but they are events. So in order to get around this, we're going to have to do explicit interface implementation. And I remember I did go over that at some point, didn't I, Jason?
I'm trying to remember.
I think you did, but I think it was a while ago in Nelson's Corner.
Yeah, actually, we did. We did.
Okay. Well, I'm doing explicit implementation in order to get around the fact that there's something else. And it's important to know that if we were to create another method inside this, and we try to access begin request, we are going to be grabbing the one that was defined in HTTP application, not the one defined in Honeycomb host. To get around that, we have to actually cast. That's backwards. We have to actually cast our this into Honeycomb host and then hit begin request, and this will execute the proper one because that's the only way to access explicit implementation is through that.
Mm-hmm.
Okay, the next step is our global ASICs MVC application is going to inherit from the application defined there. This will fail miserably because there is an application defined elsewhere, so I'm going to manually add that reference. And I'm just going to go ahead and add everything but console because we're going to need it all. And then import Honeycomb web application. Okay, so now we really have to, I think the next step would be to set up the IoC container, because the IoC container is pretty much going to be the object responsible for instantiating all of our classes. So it really is the glue that holds this entire application together. So it's pretty much the most important thing in our application, so it's a good thing to start out with. In order to add Autofac, we got to go steal its stuff from somewhere. Yeah, let's go ahead and grab those guys. We go back into that folder, drop down one, go into lib, and add an Autofac. And we're just gonna grab Autofac.dll. We're going to grab configuration too, just in case we want to use it, which we're probably not going to. We're not going to grab the integration. We're going to do that all ourselves because it's pretty trivial, and it's nicer anyway. So now we have to add references. For Honeycomb.web is currently going to be the only class that needs to have access to it. So let's go ahead and add it right there. Or it's the only class or only project that needs access to it right now. So we need a private static iContainer. iContainer being the Autofac container. Oh yeah, forgot. No underscores. And then I'm actually not going to do that right now. I'm going to do it the long way. So our begin request and end request, we're not going to implement those yet. The first thing we're going to implement is the magical protected void application start method. And then we're going to tell ReSharper that, yes, we really want to use this name. Okay, in the application start, that's where we're going to initialize our container. And I know when I first saw application start being used, my first question was, well, why can't we put this in the constructor of the application? And it's kind of interesting the way ASP.NET deals with these classes, the special application class. You'll notice that our MVC application ultimately implements or extends that. And you'll notice if we go into our global ASICs, if we right-click, and I can't remember, it's view markup, I think. Yeah, this is actually a little weird little file that defines a code behind, and it inherits our MVC application that's defined in web app that inherits this application, that inherits HTTP application. And the global ASICs file is used by ASP.NET to determine what the application class of your entire project is. This ASICs file has to be at the root of your project, or the root at your virtual directory if you're deploying to IIS. And that's how it knows which class is going to be the application class of our project. And what's interesting about how it deals with it, every single... Basically, ASP.NET determines that this class isn't going to be thread safe. So every single individual concurrent thread is going to have its own instance of application. So if two threads connected at the same time, if two browsers hit the same site at the same time, you get two application instances. They would both be instantiated, and they would be executed in parallel. And then if, let's say, one of them gets done and then another request comes in, that same instance will be reused for that instance. So it's kind of interesting in that way. If we defined our initialization inside of our constructor, it could potentially be called multiple times. And that's also why I have to use private static here instead of just private variable or private field, because there could be multiple instances of this application running inside of our app domain. We can't, if we want something that's truly is a singleton here, we need to have a private static something.
Right.
And so our application start method is the automagic method that's called by ASP.NET. It's not defined anywhere, and the documentation suck on this. I don't know. I'm kind of upset that I have to sit here and define this weird class or this weird method that doesn't override something, or at least implement something, or at least have some hint that this is what you should do.
You already said it was automagical.
That doesn't mean I like it.
That's true.
Okay, so we're going to instantiate our builder, our container builder. And then we're going to register stuff here. We'll do that later. And then we're going to set our container to our builder.build. And then that is it for now. Our begin request. So now our container's built. Remember, the container is pretty much the entirety of our application is managed by this awesome container. And in each of our begin and end requests, remember, guys, how we talked about lifetime scopes?
Mm-hmm.
We're going to be using one lifetime scope per request, and that request is going to own that lifetime scope. So, and we're going to be using the poorly documented, magical HTTP context current items thingy that allows us to set items that are only going to be available on the current request. And so, of course, this is a key object dictionary, an object dictionary. And so we're going to have to, because we don't want name collisions, we're going to do a key up here. We're going to call this request lifetime scope key. And then we're going to follow the convention that I came up with on my own, and I'm very proud of, and don't understand why nobody else does this. There might actually be a reason, but I don't know. This seems so obvious to do unique keys like this that I just don't understand. So begin request is going to instantiate our lifetime, so it's going to be container.begin lifetime scope. And it's going to stuff it in our HTTP context current items, and then our end request is going to get it back out it's going to go ahead and dispose. And then just because I don't like leaving garbage behind, we're going to go ahead and http context.current.items.remove it. And then we're going to invert this if statement because it looks nicer. There we go. So that's basically all of our objects in the request scope are going to be handled by this awesome lifetime object. And then if we have any of our objects or any of our components implementing iDisposable, they'll get disposed of at the end of the request, which is obviously really helpful for things like in Hibernate. So yeah.
So far, so good.
Mm-hmm.
Yeah, so here's our application so far. Let's go ahead and let's just set a small goal. Let's have an interface, and I'm trying to think of a good example of something that we could possibly actually even use, but I'm drawing a blank. I'm just going to use a dummy interface for now. Whoa. Thought my keyboard switched over to Dvorak for a second.
It may have.
So our goal is to get an implementation of this interface into a controller.
Okay.
And let's go ahead and make that controller. Let's call this an index controller. What am I doing?
I'm not sure.
This is a combination
lag.
of
It's lag.
It's lag. It's just
No
lag. Don't worry about
combination.
it. Yeah,
It's
just
just
lag.
lag.
Don't worry about it. I understand.
Okay. So our goal is for this controller to be executed properly.
Mm-hmm.
Okay.
So the first step is we're going to set up our just a simple, because if you'll notice, we're not actually setting up any routes here, which is going to be an issue because how is our controller going to be invoked? We're going to be setting up a better way to put our routes, set up our routes, and our routes are going to be defined in our web app, but we're going to do that a bit later. For now, we're just going to go ahead and do route collection that brought in something.
That brought in stuff and things.
System web routing.
Yeah.
Route table dot routes dot map route, which is going to bring in system web MVC, and we just brought it in the references too. Now let's go ahead and map route. Let's call this default or home page, or we're going to be removing it anyway soon. Empty URL, and then we're going to send it off to the this route is going to be dispatched to the index controller. If I could type. You know, maybe one of you guys should do the typing.
Just slow down, dude.
Okay, so that's our awesome route that we're defining. And as far as MVC goes, that is really about it. We could launch this application right now, and we should get an activation exception just to prove that this route is working and the rest of the code is working. So look for an activation exception. If it starts up. Yes. Well, message mything.
What?
Method mything. That's no problem.
Awesome.
Alright.
Missing
Wait,
method
don't worry about
exception.
it. Don't worry about it.
Which I could have sworn this was an activation exception, but I guess it wasn't. It was close, and I was right. I totally predicted properly.
Yeah, be careful about those messing methods.
So and the reason we're getting that is because the default activator that the default controller factory is using doesn't know how to instantiate this controller because it's asking for something, and it's not configured to know what this something is.
Mm-hmm.
So I guess the next step would be probably to implement the dependency resolver and the controller factory. So once I get TeamViewer to stop. There we go. Dependency resolver. Autofac dependency resolver. And this class is going to implement system.web.mvc dependency resolver. Then we're going to import that namespace, implement his members eventually. Okay, so he has get service and get services. And in order for our dependency resolver to work, remember, do you guys remember about the dependency resolver? Have we talked about this guy enough?
You did, but go ahead and give a review.
Well, the dependency resolver is something that follows the service locator pattern that ASP.NET MVC uses to resolve certain dependencies that are required for MVC to work.
Mm-hmm.
MVC is very modular, so it has things like view engines and controller factories and all this stuff, and it needs to know how to find those things to put it together. So in order to do that, it asks the dependency resolver.current singleton, which we can override with our own dependency resolver as long as we implement the iDependency resolver interface. And if anybody's remembered from, it was either MVC2 or MVC preview, MVC3 preview one, but this class used to have, it was about like 8 different members that you had to implement, and there were all the different combinations of generic and non-generic and enumerable and non-enumerable. It was just a nightmare. But they cleaned this up. We have 2 methods that we have to implement. Once we implement both of these using our container, ASP.NET MVC will basically ask Autofac to give it all its stuff, and then we can tell Autofac what to give it.
Cool.
So in order to have this dependency resolver work, we need access to our lifetime, which is right here. Or, well, it's instantiated right there, because all of our requests to objects are going to happen through the lifetime, and the lifetime will delegate to the parent if it needs to, or resolve it within the lifetime if it's request scoped. So let's go ahead and do a constructor. This is actually wrong, what I'm doing right here.
Good to know.
Yeah. But we'll get back to why this is wrong. The reason is the solution to this problem is particularly convoluted, so it's going to be kind of good to get an idea of what the problem is before we fix it. Yes, I'm using an OutParameter, and I hate OutParameters, but it's the easiest way to type this particular code. Oh yeah, we also need one more parameter. We need the current dependency resolver, or the old dependency resolver as the parent. Because we're going to delegate to the parent if Autofac doesn't find anything. And this is so that I know this could be probably a ternary, but I don't want to do that right now. This is good because now we don't have to override every single ASP.NET MVC component in order to get our stuff to work. So we're delegating off to the defaults if our Autofac doesn't find a better alternative for us. So we don't have to worry about view engines and all that stuff. And remember, this is going to be the nasty, I think they're called open generics. I think that's the actual term for them. I think they're really cool, but once I found out how to do this, I had so much fun. There's a lot of fun stuff you can do with open generics and other stuff. That's just amazing because the first big language that I learned was C++, and C++ you have templates, and templates are pretty cool. I really like the concept, and they're used for really weird stuff in C++, like weird meta programming, having the compiler calculate things like cosine and stuff, which is kind of cool, I guess. But once I got into how the generic system is handled in C#, I was just so amazed that the C++ templates look rudimentary. So here's our dependency resolver, and the next step is to create our controller factory. And if you remember, I can go ahead and actually prove this. I have to.
Don't get too excited.
No, I learned this tip a few days ago, and I just can't remember the keyboard shortcut. I guess we're gonna have to save it for another video. Fine. Basically, what you would be able to do is you'd be able to copy and paste, or copy this entire stack trace to your clipboard, and then you hit a keyboard shortcut in ReSharper, and it'll find out what each of these types of methods are and let you go and look at them. It was really cool. But I just wanted to prove right here that the controller factor that we're defining right here is the component that's going to fix this particular error. And you'll see that right here, the default controller factory is basically what it's doing is it's calling activator something activator.create instance. An activator create instance only supports, unless you specify otherwise, it only supports objects with single constructor or no constructor arguments. So this is the behavior that we're going to be overriding right here, is the get controller instance method, because that's going to allow us to inject our own code instead of having it default on the activator, which isn't going to work for us. What am I doing? We could re-implement our entire own iController factory and it would still just work, but that'd be a lot of code. Fortunately, the awesome people over at Microsoft realized that there's only a very few instances where you would want to ever redefine some behavior of the controller factory, the most important one being the get controller instance method. And this is a case of inheritance done right, by the way. Because you see that ultimately this is still going to an interface iController factory, but the default controller factory gives us, kind of some default behavior that we can override. So this is a good example of a class written well, because it was ultimately written against a well-defined interface, as opposed to most inheritance hierarchies that are written against either no or very poor hierarchies. So in order to work our never mind. I just realized that's not going to work. In order to work, we have to use the service locator, which is our dependency resolver. And this is not our dependency resolver. This is the singleton used by or provided by ASP.NET MVC. But we're going to be overriding what current returns to our Autofac dependency resolver. So we basically do current dot get service. Actually, we could do this a little bit better, I guess. No, we can't do this a little bit better. Can we? Ever actually? Yeah, never mind. Ignore me. You see the parameter over on the far right is our controller type, and then we're going to want to say iController. So our controller type is going to be the type that the controller factory determined is as the controller that this request is going to invoke. Our request context is a cool little concept. It's part of the pretty sure it's part of the web abstractions. I don't think this is something to do with yeah, it's part of the web abstractions, where it's a request context. This cool little thing where we the entirety of an HTTP request is kind of packaged into this object, but instead of being a singleton like HTTP context.current, it's not a singleton. So we can instantiate as many of these request contexts as we want and have our code still work. This is how ASP.NET MVC handles the render action, which we'll definitely be using, but I don't think we've talked about yet. Have we talked about render action?
I don't think so.
Okay, it's really cool, but that's how it does it, through this cool little request context and the controller context. So this is our implementation. You notice I didn't do a as controller. I did a cast. That's because as would not throw an exception if whatever we got back from an Autofac was not a controller. It would just return null, which would eventually still throw an exception, but this is just more explicit to where the code will fail right here if whatever type was passed in doesn't ultimately implement iController.
Right.
Which is what we want. So now we can go ahead and do our stuff in application, where we got to register our stuff with Autofac. So remember, we just do our builder dot. We're going to be doing a register type Autofac. Yay for IntelliSense. What's that? There's I swear there's a keyboard shortcut in ReSharper that shows everything in everything, not filtered by what's you're using at top. I don't know. I gotta remember what that is sometime one of these days.
Yeah, so I don't use it.
Because then I have to do stuff like, oh, there we go. It's right there. And then we want a single instance. And now we got to register our controller factory. Register type Autofac controller factory. And this is going to be a single instance. And then that's good. We are going to get an error. Yes, we are going to get 2 errors, hopefully. Hopefully they won't cover each other up. But let's go ahead and look at those right now, because there is a pretty big problem with our code right now. And could you possibly guess what's wrong, Jason?
Nope, not right off.
Alrighty. Well, if we got to get used to looking at these Autofac. Yeah, that was my bad. We never actually set the dependency resolver to anything. Yeah, that was actually the error that I was talking about. Just so you know.
Okay.
It wasn't actually. I totally forgot. We got to do our container resolve dependency resolver, which will resolve our dependency resolver we just registered right there. And now we'll get the error that I was talking about, and this will be an error from Autofac. And knowing what these errors look like will save you a lot of time. Actually, this isn't what I wanted to show you, but this is another example of an Autofac error. We have the dependency resolver taking in, and remember we want to get the parent right here?
Mm-hmm.
We have a dependency resolver taking in a dependency resolver. Autofac, not knowing what to really do with the dependency resolver, is going to try to make a circular, well, it's not going to try to, it's going to say that there's a circular dependency and it's going to throw an exception. The second error that I was hoping to show up was the iLifetime scope, where we're not actually injecting this anywhere. We're not registering this with Autofac, and Autofac does not automatically inject or expose itself to any of its dependent components. So in order to fix this, we can't actually we can, but we're not going to override this particular constructor argument. Instead, we're going to use the delegate registration, where instead of register type, we're going to do register. And I know we talked about this in the last one.
Yes, we did.
Where we pass in a delegate that takes a context, and we're going to say new Autofac dependency resolver. Then we're going to pass in scope. So let's very naively pass in, well, we can't because it's not aliased into anything. Let's just pass in null for now. And then we'll pass in dependency resolver.current, which is going to be the current dependency resolver at time of invocation, which will be before the setResolver method is invoked, because the invocation happens right here. Autofac will create this object, invoke this delegate. The dependency resolver will be the old default ASP.NET MVC dependency resolver. Then it'll set it to the new one right here. So now we have to talk about how to get the lifetime scope out of our HTTP context. And the easiest way to do that would be to create a little property, a private static property that product static iLifetime scope property called, I don't know, current lifetime scope, and its get is essentially going to be this. And its set is essentially going to be this. And I don't know why I have that above that, so there we go. And so now we can replace this code with that, and we can replace this code with that. So yeah. Now we can access our current lifetime scope, and we can go ahead and pass it here. And as long as I didn't make a mistake, this will work for one request, and then it'll fail. So let's go ahead and see. Actually, no, it's not going to work. Yeah, parameter cannot be null context. Okay, before we set the resolver, let's go ahead and cheat and set the current lifetime scope to container begin. We're going to have to do this anyway because when application start runs, the begin request, or actually, we never set up begin request or end request. You guys weren't paying attention.
It looks like you weren't either.
I'm the one talking. I don't need to pay attention.
You're talking at 900 miles an hour, like our other viewers. I'm just trying as well as I can to keep up with what you're saying.
Is there anything that I need to?
No, just remember, I'm playing the role of student too, like a real student, because this is all still new to me, and so I'm trying to follow along with what you're saying. And you're talking with a little extra pep in your step tonight. I think we could clock you in at a good 80, 85 miles an hour. What do you think, Zach?
I think we can go 88.
Oh,
He's
do you?
going back to the future.
I'll try to talk slower, but there's a lot of stuff to cover, and it's kind of... Okay,
It's kind
so
of what?
So here are our two automagical methods that we're going to be invoked on ASP.NET's going to invoke for us on every request and every end request.
Mm-hmm.
And now we're going to get an awesome error. And the error is going to prove to everybody that begin request gets invoked. Hold on.
Or that's what it should have proven.
Get service. Our dependency resolver is being invoked before the dependency resolver. Ooh. No. Autofac dependency resolver. Dependency resolver.current. Let's think about this for a second. We're setting the resolver right there, so a call to current should not invoke anything. So what's it trying to context 22. No, never mind. I'm being dumb. Line 22. Service type is null. No, scope is null. Of course scope is null. I set it to null. Yeah, okay. Ignore me. You threw me off, Jason, telling me I'm talking too fast. I was...
Kind of are.
It's all good. I'll take the blame for it.
Okay, so, I forgot what I was saying. We have to set up our begin request and our end request, so now we can prove that these are being run. Hopefully. Yes. So there's proof that our begin request and end request are being invoked before our application start. Unfortunately, that should be throwing an error right about here, because our container should be null. So let's go ahead and see what happens. Begin request container. Container is set up properly. That's bizarre. Oh, I might have been actually totally wrong about that order. Ooh, yeah, it's the other way around. Yeah, so we have to instantiate our container, but our begin request is going to be invoked afterwards, and we don't want to instantiate another container. And the whole reason I was trying to bring that up is because we have to do this in begin request. If current lifetime scope does not equal null, then dispose of it. So that right here, before our call to set resolver, we can go ahead and set up our current lifetime scope. So it's going to be container dot begin lifetime scope, so that our dependency resolver will work during application initialization. So obviously we need access to our dependency resolver, but in order to have access to our dependency resolver, it depends on the current lifetime scope. In order to have access to the current lifetime scope, we would normally have to begin a request, but unfortunately begin request gets invoked after the application start, meaning that we need to instantiate this for this one time of application initialization before we can use it.
Okay.
And this will finally get... no, it won't. So remember how we set up our iDummy interface?
Mm-hmm.
We haven't provided an implementation yet, so we'll get a nice little error saying that there's no implementation found. Let's go ahead and implement our dummy thingy in here. Because if you remember, our services is going to contain the implementation for most of our services defined in our base, so that we don't have to re-implement these if we move from a web app to a console app.
Right.
And we don't want to implement them in base because that kind of defeats the contract of base, which is just to provide a bunch of interfaces that our code can grab onto during development and have them filled in later. So let's go ahead and implement our what do I call that guy? Implement our dummy interface service, which is an awful name because it shouldn't have the word interface in it. And this will we'll go ahead and bring in our Honeycomb base into our references, which is nice for it to do it for us automatically. Then let's go ahead and provide an implementation. So here's our implementation. Now we have to wire it up with Autofac. Right now, we're going to put that in our application. Later, we're going to be doing something cool that's going to kind of break up our registrations in a really nice and modular way. But currently, we only have one place that we can access Builder, which is right here. So let's go ahead and set up our registration. So let's set up our dummy interface, and let's hope that's public. It is public. So now our Honeycomb web is referencing our Honeycomb services, and we brought in a using statement at the top. And we're going to say as iDummy interface, and then we don't care if it's instantiated per dependency. Okay, so remember that error I was talking about 30 minutes ago, probably?
Sure, absolutely.
Yeah, I do.
Well, you're about to see it once I refresh twice. No, you're not going to see it.
I was willing to put money on we weren't going to see it.
But we did see an error, you know?
Oh, I was
it's not
willing
really
to
the
put money on that too.
It's not the star of the show, but, you know, it is some celebrity.
Okay. Yeah. Everyone, like, I've done this. This is just like the virtual thing. I've spent so much wasted time because I forgot to actually register this component as something.
Right.
I don't understand why Autofac does not throw an exception when you register a component to 0 services. Not even as itself.
Easy, Nelson.
I don't get that. But we have to go ahead and instruct Autofac to hand out an Autofac controller factory whenever it's asked for in iController factory.
Mm-hmm.
There we go. I should write them.
You should.
Autofac, yeah. Tell them that they need to throw an exception if you don't register your components as anything. Okay, now we'll get that stupid error. The second, no. Controller for the name index. Huh?
We're working our
Kidding
way
me?
up to it.
Yeah, that's actually because I didn't actually register our controller with anything. And that's the unfortunate part about this particular setup, is that our web app is actually going to have to make its own registrations, because our controllers need to be registered as themselves. Because if you remember our wherever you are, our Autofac controller factory just asks for an instance of whatever this type is. This type is going to be index controller, so it's asking Autofac for an index controller. So we need to register the index controller as itself. So let's go ahead and do that, but we can't do that because we can't have a circular dependency between Honeycomb Web and Web App. To fix that, I'm going to go ahead and I'm going to go ahead and make this abstract. And then somewhere, probably right here, I'm going to do a protected abstract void register components and pass in a registration or a component builder or a container builder. And then I'm going to go ahead and invoke that during this, so that it can register its own stuff. And now you'll see our global ASIC is going to throw an error because we're not implementing the register components. Now we can go ahead and reference Autofac because, okay, you'll notice that Container Builder, this is actually going to bring up a reference Autofac and use Autofac Container Builder. Let's see if it does what I think it's going to do, because it's done this to me a few times. Because this is actually a very common... Yeah. See this path?
Mm-hmm.
It's referencing source web app bin Autofac.dll, which is... I don't know why it thinks that this is acceptable, but it's referencing a reference inside of the bin folder that's cleaned on every rebuild. So we're going to run into errors. Eventually we'll run into errors. Right now we're not going to run into errors, but eventually once we do a clean or some weird combination of weird Visual Studio-y stuff, we'll get a huge error. So we want to make sure that whenever we use ReSharper, or we should never use ReSharper to add a reference to anything that isn't in the BCL or isn't in our current solution, because it's going to totally screw it up. Does that make sense?
Mm-hmm.
Okay. So now we're going to go ahead and manually add our Autofac.dll. And if we right-click Autofac, we'll see that we have our proper path to our lib folder.
Cool.
Okay, so now now that we've referenced Autofac, we now have access to this container builder, so we can now go ahead and register our index controller. And I'm going to cheat, and I'm going to use a register types in assembly, or register assembly types. And then I'm going to do type of MVC application dot get type, or assembly. And you'll notice me doing... I know I'm going... I mean, do you guys mind all the side tracking I'm doing here?
No, it's fine.
Do what you got to
It's
do.
kind of important stuff. You'll notice me doing this a lot. Type of, the current type, and then .assembly. And the reason I do that is because if you do... The alternative to this is assembly.get executing assembly, or assembly.get calling assembly, or get type .assembly. But there's a problem with this. And the problem is that get type will always return the current type of this assembly, or of this type. So if you're calling get type within a base type, and the type you're actually working with is a child type, it's going to return this child type .assembly, which will be whatever the child's defined in. So don't ever do get type.assembly if you're not expecting that behavior. Always do type of whatever your class is in .assembly. And I can show you that by looking at the global ASICs again. And you'll see that it inherits web.app.mvc application. The class that this generates is going to be a class that inherits this class, but it's going to be defined in a different assembly. So we always want to make sure that we're not using the polymorphic, or the polymorphic get type. We always want to make sure that we're using the compiler construct so that ASP.NVC or ASP.NET can't screw with our stuff. Okay, so then we're going to pass in a where, and we're going to do a type of iController which is system web MVC, is assignable from t and t.name.ends with controller, and then we're going to say as self. And this says that we are going to look for every single class in our current assembly, and we're going to see if at any way we can derive it or cast it into an iController, and then we're going to also make sure that its name ends with controller, and then we're going to register it with itself. And this will pick up pretty much every single controller in our assembly.
Okay.
And the reason, actually, there's a reason why this is acceptable and other kinds of auto registration aren't acceptable. Like someone might ask, why don't you just register every single type of your thing in Autofac? And the reason this is because controllers will always be registered as themselves, and most importantly, controllers will always be registered with the default instance per dependency. And that's going to be the default. And instance per dependency is cool because every time someone asks for this type, Autofac will instantiate a new copy of it. And the reason that's important is ASP.NET MVC requires that every time it asks for a controller, it gets a new instance. And that's important when we start talking about render action, which creates little sub-requests inside of our application. And our controller might be invoked more than once. MVC will throw an exception if it gets a same iController that's already been used.
Okay.
I personally think that requirement's dumb and is probably a result of poor coding, at least on the controller part. But whatever. What am I? Okay, so now our controller is registered. What was the error that we're getting anyway? Yeah, that's fine. So now we can go ahead and launch again. And I'm not going to say it this time. Yeah, that's not what I wanted. Let me go ahead and debug this and find out what it's trying to find.
I love how our ultimate goal has been to work our way up to the appropriate error.
Object reference not set to an object. Are you kidding me? Huh? Passing in the proper service type. Try resolve service type. Let's check out our scope. This is also important when you're debugging Autofac. Always check out the component registry. The component registry is really cool. If we look at registrations, we'll see every single object that's been registered with Autofac. And now we can see that our lifetime scope has been our dependency resolver, our controller factory, our dummy interface, and our index controller. And most importantly, we can find out what services that they implement. So, for example, our Visual Studio debugging screens fail. For example, we can make sure that our dummy interface is indeed services count 1, dummy interface, which is good, and our index controller is properly set as itself, which it is. So this is kind of bizarre. There's probably some weird inner exception. There's not a weird inner exception. Ooh, our scope might be disposed. It doesn't give me a nice little
You want to pause for a minute, Nelson?
No, I'm good.
Okay.
I'm good. Give me one more try at this.
Mm-hmm.
Just thinking out loud.
No, it's all good. It's actually nice to hear the process as much as we can.
Add instance for disposal, lifetime scope resolve component, resolve operation component activation, activate. Reference not set to an instance of an object that could possibly be in our constructor. Let's go ahead and actually prove that a constructor is being invoked. That's the next thing you want to check with Autofac. If you ever get weird exceptions like that, you want to see if... So here we go. Our our dummy object is being set to null. Or no, never mind. It's being set properly. I'm dumb. So let's go ahead and see if our action is working. Our action is not. Who is trying to tell this what to do? I give up.
Okay. All right. So you ready to pause it for a second?
Yep.
Okie doke. All right, Nelson, you've got control back. We're back from our pause now.
Yeah, well...
Interesting.
Unfortunately, the entire time we were getting the error that I've been trying to lead up to, but we were getting it at a place that I wasn't expecting because I wrote this code backwards. So you'll see that when we go ahead and launch, we'll get that error. We'll get the object reference not set to an instance of an object. Unfortunately, this is very cryptic. The first time I've actually ran into this error, so I'll have to remember to look out for it. But the issue is this code right here. This code is saying on the begin request, and if you remember, begin request is executed after application start. If the current lifetime scope is not null, then dispose it. Otherwise, create a new one. This is actually backwards. What I really meant to type when I wrote this was if current lifetime scope is null, then create a new one. And now, by changing that, we'll get the exact error that I've been talking about this whole time, which is that the first request will work fine, but every other request will throw an error.
Okay.
And that particular error that we were getting before, the only reason we were getting it before prematurely was because we were reinstantiating our current lifetime scope. Now, the reason we get this error is because of this line right here. The Autofac dependency resolver is taking a reference to the current lifetime scope, which means that the current lifetime scope that's instantiated right here, remember that the current lifetime scope is instantiated right here, then the dependency resolver is instantiated, which means this line of code will execute right here and not right here.
Right.
Which is kind of confusing, but that's why it works, because we're setting the current lifetime scope to something right here, then we're setting the resolver. But the issue is that, like I said, we're setting this to a reference of the current lifetime scope, which is being instantiated right here. Once this current lifetime scope gets disposed of, then our dependency resolver is no longer pointing to a valid lifetime scope. It's pointing to a disposed lifetime scope. And that's going to be an issue, obviously. So to fix that, we're going to introduce, or I'm going to introduce, something called a closure. And I don't think we talked about this in Nelson's Corner. But I'm going to go ahead and write this code out. And if any of you guys have been following out with Nelson's Corner, you should be able to follow at least what this code does. Our Autofac dependency resolver is taking a delegate that's going to return an iLifetime scope every time it's invoked, and then it's setting that to a member. And then every time it needs to get a service, it calls this method, and this method will then be executed every single time it needs a service. And so currently this isn't a closure, this is just delegate. To make a closure, what we do is we pass in a lambda here. And this lambda is going to be really interesting, because it's literally going to be current lifetime scope. So I'm first going to prove that it works. Just so people can gain at least a little bit of confidence in me before we stop this video. And if we keep on refreshing, we see that we still get what we want. Now, the reason this works is because, remember when we talked about hoisting?
Mm-hmm.
Current lifetime scope, the reference to the property, not the reference to the value. That's confusing. What we're doing is we're providing a reference to a property instead of providing a reference to a lifetime scope. And this property will always return the proper lifetime scope depending on what is available in our HTTP context current items, which is always set on our begin request and our end request. So now that we've closed this variable, we can now access it safely inside of our dependency resolver, and that will always return the proper lifetime scope. And that'll always be the one lifetime scope per request, and we won't get any of those nasty null errors. So yeah, Now I can close all of this, and I'll show everyone what we've managed to do. We have managed to define an interface in our base, implement the interface in our services, consume the interface and the implementation in our web app by just referencing the interface and using it in an action. And I'll just show that that works again. Yep.
Cool. So is this a pretty good place to call it now that we've got right past that? You did manage to demonstrate what you were getting at as far as the error that you were expecting, and seeing how we're about an hour and 11 minutes in.
Yeah, yeah. I mean, we got to where we set off to do in the beginning of the video, which was to get our iDummy interface printing in our index controller.
Awesome. All right. Well, we'll go ahead and wrap it up here, and we'll pick back up in the next episode and continue with this application. So, everyone, thanks a lot, and have a good one. We're out of here.